So let's say you're working on a project with Raspberry Pi where you need multiple cameras to work together. Now, obviously, the first thing you will think is maybe you can use 4 different webcams with Raspberry Pi, because obviously Raspberry Pi has these 4 USB ports. So without using any third-party USB hub, you can actually use 4 webcams together. Now, the thing is, webcams are not that compact, and secondly, they are pretty much expensive. Now, coming like in the opposite side, Raspberry Pi cameras are very compact, and also nowadays we have different kind of Raspberry Pi cameras. Like we have the wide cameras, we have the like microscopic lenses for Raspberry Pi camera, different kind of qualities. So we have many more options coming to Raspberry Pi camera, and also they are like compact. Now, but in Raspberry Pi there is only one port where you can actually connect a camera, Raspberry Pi camera with it. Now in this video I'm going to show you how with the Raspberry Pi, any Raspberry Pi, so it can be 3, 4, so I'm going to use 4, but you can use 3, 4 or even 0. How you can use 4 different cameras, 4 different Raspberry Pi cameras together in a Raspberry Pi. And for that we are going to use something called a multi-camera module. So I'll show you how multi-camera module works and how we can connect 4 different cameras with a single Raspberry Pi, and we can simultaneously access those cameras. Not actually simultaneously, there will be a little delay, but yeah, you can say almost simultaneously. And also I am going to use only 4 cameras, but you can use more than that also. And I'll also tell you how you can use more than 4 Raspberry Pi cameras with Raspberry Pi using the same module. So let's get started. Okay guys, now let's talk about the hardware part. Now here we have the ArduCam multi-camera module. As you can see, this is how the packaging looks like. Okay, and I'll provide the link in the description of this one. So if we open this, let me just open it. So you will get a manual, which obviously for now we don't need. And next we are going to have the module itself. So if I just take the module out, as you can see, this is how it looks like. Some nuts and screws we don't need for now. You need the screws if you have to like mount it with a Raspberry Pi. Okay, let me zoom it properly. Now this is how the multi-camera module looks like. Okay, so this is basically the input. So we are going to connect here, we are going to connect it with Raspberry Pi using a flex cable, and that cable is given and somehow we have missed it. So let me take it out. Yes, so this is the small cable, flex cable they have given. You can use a bigger flex cable also, but here they have provided the smaller one. So this flex cable we are going to connect with the multi-camera module and Raspberry Pi. Just yeah, and then there is here we have this 2 connectors here and another 2 connector ports. You can say ports here. So these 4 ports are for 4 different cameras. And if you see it, you can see like it's written as camera A, it says camera C, and in the opposite side you will see this camera B. I'm not sure if you can see it properly. You have the camera B and you have the camera D. Okay, so and basically these pins are going to connect with the Raspberry Pi. Okay, this is how simple it is. So now I'll just connect the cables first. So the cable will go in this way, so this one will go like this. So direction is very important, and this one will going to go here. Okay, and before we connect it, I am going to also install the cameras. So I am here using 4 version A cameras. So it's specifically version 1.3 old cameras, Raspberry Pi cameras, but I have also used it with Raspberry Pi official camera 2 and official camera 3, and with all those cameras is working just fine. Just one thing you have to remember, that all the cameras must be of the same resolution. Okay, so all these cameras are of same resolution, so you have to use, if you use 4 cameras must be of same resolution. Okay, this is a very important thing to note. Now let me just connect the camera. So here as you can see, I have connected all the cameras. So 1, 2, and in this side we have 2 cameras. So 3, 4, all the cameras we have connected, and finally we can actually connect these pins. Okay,
and this is how it is at the end of the day going to look like. Let me just zoom out a little bit so you'll have a better view. So as you can see, this is how it should look like. So two cameras, and here we have two different cameras. Okay, now these are small flex cables. Now these are default flex cables, but there are also 1 meter on 2 meter flex cable you will find online. So you can use those flex cables if you want to have the cameras in different places. Okay, and yeah, this is the main thing. And also the thing I already mentioned, that the camera should be of same resolution. Now these are 5 megapixel cameras. You can also use 8 megapixel cameras and also use 12 megapixel cameras. Like up to 12 megapixel I have tried. The Raspberry Pi 3 official camera is 12 megapixel camera, and have tried on that one, and that has worked perfectly. Okay, and also the Raspberry Pi camera version 2, that's the 8 megapixel camera. In that also I have tried, and that also works just fine. So all those cameras I have tested and they are working just fine. So this is about the connection. Very simple. Just connect the cameras, connect the cable with the Pi, and just you have to attach in this way. That's it about the connection. Now we will see how you can install the libraries and how you can access these cameras using the Raspberry Pi. Okay everyone, so now the hardware part is done. Now we are going to look into the software part. So here will look like what libraries we need to install and how we can run the code so that we can like access the different cameras using the multi-camera module. Okay, so the very first thing is here. So here I am going to use the latest Raspberry Pi OS. As of now it's Bullseye. So I'm using 32-bit Bullseye full desktop version. I also recommend you to use the Bullseye latest version only, because if you use any other previous versions like Buster or something, you will not have the lip camera installed. So you have to install lip camera and other stuff. So just install the Bullseye version, so it will be easier for you. Okay. Next is here I have connected to the VNC. You can just go connect the Raspberry Pi through desktop or whatever you want. Okay. Next is here you have to install the OpenCV library for this. Now OpenCV I already have installed. So if you see Python, if I just do import cv2, it's already been installed. So if you don't know how to install OpenCV in Python, I have a video in my channel on that. So I'll put the link in the description. Just go to that video, check the description of the video, follow the steps, and you will have CV to install in your Raspberry Pi within 5 to 10 minutes. Okay. Next is we also need lip camera, like I said, but lip camera will be pre-installed, so you don't need to install it in Bullseye. Next is we have to enable the I2C. So we'll just write sudo raspi config, and we'll get inside it, and here we are going to the interface options, and there we'll have I2C. You have to enable I2C. Just click yes, okay, and finish. In your case it may ask you to reboot, so just reboot. Okay, and now we are done. Now we just need to download the codes, and you have to run it. To download the codes, you go to this GitHub repo. The link will be in the description. So you just copy the GitHub link, and next we are going to clone it. So I am going to go to desktop, and I'll just do git clone, and I'm going to paste the link, and it is going to clone the repository. Okay, so once it's done, just wait for it. So now we have the repo. Okay, now I'm going to inside this. So I'm going to install Raspberry Pi. Inside that I have to go to inside multi-camera adapter. Inside that multi-camera board 4 channel, and then inside that multi-camera adapter version 2.2 Python. This is the whole path. Okay, so make sure you go to the exact same path. Now remember, version 2.2 is the board version number I'm using. So there is a previous version as of now is 2.1. So don't use that, just use 2.2. This is I'm using. And if you have board 2.1, then you have to use the legacy. So in the last, so here with this version 2.2, there is also a folder called legacy. In that case, you have to go to a legacy folder. Okay, so you go inside this folder. I'll just clear the terminal, and now we have these files inside it. Okay, now we are going to run the init camera sh. Now before that, we have to give it permissions. We'll write sudo chmod +x and init camera sh. So we are going to give it executable permissions. And once we are done, now we have installed OpenCV, we have enabled I2C, we have lip camera already installed, we have downloaded the library, and we also have we have completed our hardware connection. Now we are ready to actually run this code. Okay,
So if I just shoot init camera sh, but before running, just let you know that I am using 3 cameras here for now, because while testing I just checked that one of the cameras actually was faulty. So I'm just using 3 cameras, but similarly you can use a 4th camera also with the same setup. Okay, so let me run it, and here you will see it is testing the very first camera. So this is the very first camera. As you can see, you will see my hand here, very first one. Now automatically it will switch to camera B. So this is the camera B. Okay, and now it is switching to camera C. So this is the camera C. Okay, I don't know, yeah, you can see my hand. This is the camera C, and finally it will switch to camera D, but there is no camera D attached, so it will give us an error. Now I know you are thinking that why those kind of pink lines were there. Now this is basically issue I just found with this module. Now the thing is, it can be solved. So basically the problem is, which basically the connections we did with the basically the pins we have connected. Basically the pins got like, they are sometimes, I don't know, they are maybe sometimes loose. So that's why we get this kind of noise here. But the solution to this is you have to use jumper wire. So I also have the same module in some of my device, and I'm actually using it in a regular basis. So what you have to do is you have to connect. So basically here what we did, we just put the module over the Raspberry Pi, and I don't know, but maybe the pins are like, some pins are maybe loose or something. So what you have to do, you have to connect those pins. Instead of just putting the multi-camera module over Raspberry Pi, you use jumper wires. Or the best thing you can do is maybe you can solder. So don't solder directly to Raspberry Pi pins. You can use some kind of like a female pin, and then using that you can solder. So soldering will be the best option, but also you can use jumper wires. Okay, so you have to make sure that your pin connection is very like rigid, and if it is that's the case, in that case you are not going to get any kind of noise. Okay, also you have to make sure the flex cables are also like in the camera port, the flex cables are tight. Okay, and if that is the case, in that case you are not going to get the noise. Okay, now let's just talk a little bit about the code. Also, if you are going to connect with the jumper wires, I'll show you the connection, don't worry. So here inside this, we go inside this, and from there this, and here. So basically this is the code we just checked, init camera sh. Okay, and basically these are the last 3 captured images. So this is for camera 1, as you can see, it will automatically save. This is for camera 2, and finally this is for camera 3, as you can see. Now as you can see, the image size, image quality is, obviously image quality depends on the camera. So here I'm using just 5 megapixel camera, so quality is not that bad. Okay, so this is set. And now let's look at the code we have just used. So if you see, it's very simple code. So it's basically using I2C to detect that if this I2Cs are present or not. So if the I2C connection are not present, it's going to give you error. Similarly, it will search for like dev video 0. So if it can find it, it will also going to give you error. And if all these conditions are fine, it's going to run this adapter test demo.py. Now just let me show you adapter test demo.py. Just let me open it. So as you can see, we have it. So now as you can see, we are not using OpenCV here, but still I have said you to install OpenCV. I'll show you why. So basically, as you can see, basically there are 3 jumper wires, 7, 11 and 12. Using these 3 jumper wires, it is basically changing the cameras. Okay, so if you know multiplexers is something like that, you can say. And then there is this I2C connection. Basically this I2Cs, using this I2Cs is basically getting the data. Okay, so basically every time you are switching a camera, you are basically switching those you are basically those 3 GPIO pins, you are making some of them high, some of them low. So let's say 001, 100, 010, something like that. Based on that, this is selecting the camera, and also basically we are changing the I2C. Okay, so in the similar way, in your code, you can just use the I2C. For example, if you have to use camera A, you just use this settings. So you use the I2C connection this, and the GPIO outputs this. And then if you capture, you are going to get, or even if you use normal CV2 capture function or any other function, you are going to get the normal the camera you have selected. So in this case, camera A. Similarly, if you use this I2C and this GPIO outputs, you are going to get camera B, similarly camera C, similarly camera D. Okay, so this is how basically by making the pins high and low in a specific order, and by selecting the I2C, you are going to get the exact camera you want. Okay.
Now there is also a preview OpenCV file. If you see this, in this file they are using OpenCV, and if you use this file you are going to get like 4 cameras together in a single screen. Okay, but here I have 3 cameras, so I'm not going to show this. And also this is using PyQt5, and I sometimes it's little laggy. So if you have 4 cameras working properly, then only it works properly. Else if you have 2 or 3 cameras, sometimes it give you error or it get hanged. So there is still, this code is little buggy, I would say. So if you only have 4 cameras working, then only it may work, and otherwise you may get error. You will not get error, but your like that program will hang or something like that. Okay, so that's the problem. Now if you have to do the jumper wire connections, in that case you don't need to connect all the 20 pins. You can simply use these pins only. So these are the main pins which basically this module uses. So this 3.3 volt pin and ground pin to get the power. Then there is this SD and SCL pin for the I2C, and finally those 3 GPIO pins, pin 7, like pin basically GPIO 4, GPIO 17 and GPIO 18. So these are mainly the 6 and 7 pins basically this module uses. So if you are going to connect it through jumper wires, or you are planning to solder it somewhere, something like that, you can use this 7 pins only, and it's going to work just fine. Okay, so this is how this module works. Now like I said, like these modules have few issues. Like I have found out that this noise thing, so if there will be very small amount of like connection will be little bit loose also, you are going to get a lot of noise. So that's one issue. So but yeah, still you can fix it actually if you just do those things I just mentioned, like use jumper wires, or you just solder it, or check the flex cables properly. In that case, in that way you can actually solve it. But still I would not say it's very robust. So yes, you have to put a lot of effort to get all the cameras very like, so if you want to ignore noise completely and you want all the cameras footages to be completely good, in that case you have to put a lot of effort. So that's one thing. And except that using the multi-camera module is not that complicated, it's simple. So just add the I2C connections and the GPIO pins, so you can simply integrate it with any Python program, integrate it with OpenCV. Okay, you can check that OpenCV code actually, that what is name, just let me check. So it's preview OpenCV, that thing you can check. So in that case, in that code you will get to know like how in OpenCV you can actually use the cameras. Okay, also in the bullseye camera you can use Spy Camera 2 to get the footages. If you're using this multi-camera module, you can use Spy Camera 2 to get the footages. Maybe in some other video I'll just show you how you can do that. So overall it's a good camera, a good module if you want to use multiple Raspberry Pi cameras. And now if you want to use more than 4 Raspberry Cameras, what you have to do? You have to do nesting. So basically with a single multi-camera module, you connect 3 cameras maybe, and then in one port you just add another multi-camera module, and with that multi-camera module again you add 4. So now 4 and 3 you have 7. But again, for that one again you have to do a lot of things. You have to mess with the I2C. Okay, so I2C will be a little bit complicated, but you can actually do that. And also you have to take care of the GPIO pins also. So previously you were just handling 3 pins, now you have to handle 6 pins together, and I2C will also get little complicated, but yes, it's feasible. So actually with this, by nesting this multi-camera modules, you can use more than 4 cameras also. So this is about the multi-camera module, and if you have any queries regarding it, please let me know in the comment section. I will try to reply you back. And also many more videos are actually coming, so stay tuned to know more about those. So thank you, and I'll see you in the very next video.